Hi students, welcome to you everyone. Today in this class I am going to explain you about the concept of power students. Already in the previous classes I explained you about work and energy. Now I am going to explain you the concept of power students based on the students levels. That means this video students helps to the people those who are interested to learn the basics or the foundation course for the IIT. Definitely this video helps to them students. Okay, see here, first of all, what is power? Power is the rate of doing work, students. Power is the rate of doing work or work done by unit time can also be treated as power. Students, one thing you understand here, like energy, power is also associated with the force. That means simply it tells us about how rapidly the work has been done, students. Okay, based on all this, we can define simply it is power is the rate of doing work. See here. What is power? The rate of doing work. The rate of doing work is known as power. It can also be defined as work done by unit time, or work done for unit time is known as power, students. See here, power can be represented as, it can be represented as, it can be represented as P, letter P, students, or can be represented as P. Formula to find out the power can be written as, that is, power is equal to work done by time, students. Do you know, students, work done means, sometimes in terms of work done we can write energy consumed or energy transferred per unit time. So that power can also be written as energy transfer per unit time. Okay, students. So simply it can be written as P is equal to work done by time or energy by time, students. See this. Based on these, students, we can decide the units of the power. See, units of the power, based on this formula we can say easily. Okay, don't memorize these units. Just see the formula and write the units, students. We know power P is equal to work done by time. See here, CGS unit of power is, CGS unit of power is, see here, form to find out the power work done by time. CGS unit of work done is hour. So hour for time seconds. So Earth per second is the CGS units of the power, students. Also, SI unit of per SI unit of power is, see here, SI units of work done, joule, time, seconds. Do you know, students, one thing you remember here, that is units of time. Whether it is in CGS or SI or MKS, whatever it may be the system, the units of the time is same, that is second. And students, here remember this one, joule for seconds is the units of power in SI system. The term joule per second is represented as watt, WATT, watt. This is the SI units of the power, students. SI units of the power is watt. 1 watt is equal to 1 joule per second. From this, 1 joule can be written as watt second, watt into second, students. Taking cross multiplication here. By taking the cross multiplication for the above expression, we will get the joule is equal to 1 watt second, students. Joule is the units of work done or energy in SI system. Work done or energy, students. Thereafter, students, one more unit is there, that is FPS system. Power can also be measured in horsepower, students. What is that? Horsepower. FPS. Unit of power is horsepower. Horsepower, students. This is the FPS unit of the power. Simply it can be written as HP. 1 horsepower is equal to 746 watts. These are the relations between the FPS unit of power and SI unit of power, students. 1 horsepower is equal to 746 watt. 1 horsepower, that is the FPS unit of power, is equal to 746 watts. This is SI unit. FPS unit of power is horsepower, SI unit of the power is watts, students. Also, going to tell you relation between the CGS and the FPS units of power, students. We know that 1 horsepower is equal to 746 watts. Here, students, instead of watt, we can write joule per second, students. Joule per seconds. We know that, students, already explained you while discussing the concept of the work. 1 joule is equal to 10 power 7 per second. Now we can write 746 into 10 power 7 earth per seconds is equal to 1 horsepower. This is also the relation between the FPS unit of power and CGS units of the power, students. Okay. Next, commercial unit of power, students. Commercial or practical unit of power. Is commercial unit of power is kilowatt. Students, 1 kilowatt is equal to, kilo means 1000, numerical value is 1000 watts. Similar to that, students, commercial unit of energy, we already know that power into time. Since from power is equal to energy by time or work done by time. From this energy is equal to power into time, students. Here we can write the commercial unit of energy, commercial or practical units of energy. Based on this, we can say that commercial unit of energy is, here students, we can call this commercial or practical unit of energy is kilowatt hour, students. See generally formula here, energy is equal to power into time. Units of power is watt and time is hours, not in seconds, hours. And instead of this we can write kilowatt hours. Kilo indicates that, the prefix value of kilo is equal to 1000, students. So substitute here 1000 into watt into 1 hour is equal to 3600, students. Here firstly we must know that commercial unit of energy is kilowatt hour. This is also called as practical unit, commercial unit of energy or practical units of energy. Students, here I am going to tell you relation between the kilowatt hour and the joule. Seconds, students. 1000 into 3600, here watt into seconds, watt seconds. 1 kilowatt hour value is equal to, here 36 into 10 power 5, students, the simplest form of this, watt second. Do you know 1 watt second is equal to 1 joule? So 36 into 10 power 5 joules is equal to 1 kilowatt hour, students. 1 kilowatt hour is equal to 36 into 10 power 5 joules or 3.6 into 10 power 6 joules. If you take the point here, you get the power 6, students. Okay, this is the commercial unit of energy. This energy, this practical units of the energy is equal to 3.6 into 10 power 6 joules or 36 into 10 power 5 joules, students. We already know that joule is the unit of energy or work done, students. Okay, next, students. I am going to explain you the relation between the average power and the instantaneous power. Before going to it, we must know about average power and the instantaneous power. Firstly, I will write here average power. Simply we can write work done by time, students. Total work done by total time taken. And the instantaneous power, expression for the instantaneous power. See here. P instantaneous is equal to dW by dt. Here, students, considering this will be considered at small intervals of the time, very small, so that we can write dW by dt. From this, work done is equal to force, that is constant, into displacement by total. Separate that one. And this is force. Rate of change of displacement is known as velocity. This is the expression for the instantaneous power, students. See once here, instantaneous power P is equal to force into velocity. This is here dot product, students. Power P can be written as Fp cos theta here. Power P can be written as Fp cos theta. This is the simplest form of the dot product of force and the velocity, students. Here, depending upon this angle theta, we should get the value of power is positive, negative, 0 also. Here, if theta is equal to 0 degrees, then we have theta is here, students. This is the angle between the force and the velocity. Theta is the angle between the force and the velocity here. If theta is 0 degrees, that means force and the velocity both are acting in the same direction. Then that time we will get the power P is equal to Fp cos 0. Cos 0 is equal to 1, students. So we can write power P is equal to force into velocity into 1, that is Fp. We will get the result is positive here in this expression. And also, if theta is equal to 90 degrees, we know theta is the angle between the force and the velocity. That means force and the velocities both are acting perpendicular, assuming here. Then we have power P is equal to Fp cos 90. Do you know, students, cos 90 is equal to 0. 0 into anything is equal to 0. So power is here 0. Right, students? Next one. If theta, that means angle between the force and the velocity is 180 degrees. In this instant, force and the velocities both are acting in the opposite direction. And considering a vehicle which is moving constantly in eastward, force of friction which is developed between the tires of the vehicle and the road acting west direction. Here, force of friction acting between the tires and the road acting west, and the velocity of the vehicle is towards east, students. Here the power can be calculated by using that negative, because both are acting in the opposite direction. So here, considering that situation, if the force and the velocity both are acting in opposite, at that time we should get angle between them is 180 degrees. If cos 180 is theta is equal to cos 180, then theta is equal to 180 degrees, then cos 180 is minus 1, students. Here we get, then we have power P is equal to Fp cos 180 degrees. Cos 180 is minus 1, so that we get the result is minus Fb. That is, result is here negative, students. So based on these three, we can say that power can be positive, can be negative, and also can be 0. See here, based on this expression, we can say that power can be positive, power can be negative, power can be 0 also, students. Power can be positive, power can be negative, power can also be 0, depends upon the angle between the force and the velocity, students. Relation between average power and P instant, shortcut we should write here, P instant. Just before now, students, express the expression for the average power and the instantaneous power. From there, considering here a particle which starts from rest moving with constant acceleration, that means force acting on it is constant. After certain intervals of the time, that means after t seconds, its velocity to be v starts from rest, students. A is equal to constant. After t seconds, v is equal to u plus at. v is 0, then we should get here at. From this, A is equal to V by T students. We know that average power can be written as total work done by the time taken. From this, work done is equal to work done by the force acting on the object is equal to change in kinetic energy by time. From this, we can write K final minus K initial by T. Here students, K initial is 0 because initial velocity is 0. So K initial is 0. So we can write K final, that is half mv square whole by T. What is this students? P average. Then after we can write P average is equal to half m. We can express this one in terms of dot product. We can write V bar dot V bar. Dot product of a vector by itself can be written as square of the magnitude of that vector. So here V bar dot V bar is equal to V square whole divided by time. So from that, P average is equal to half into m into V bar dot V bar by T bar students. Instead of this V bar by T bar, we can write half m V bar dot A bar students according to this relation. A is equal to V by T. This is the magnitude of the acceleration. We can express this one in terms of vector form. So A bar is equal to V bar by T. From these students, we can modify the equation m A bar dot V bar students. See students, here dot product obeys the commutative, so that A bar dot V bar is equal to V bar dot A bar. From this we can write half into m into A, force, mass into acceleration can be written as force into velocity. We already know that the force into velocity is equal to the dot product of the force and the velocity can be equal to instantaneous power students. So that here we can write half into P instantaneous is equal to P average. See this? P average is equal to half into P instantaneous. Finally, we can write here instantaneous power, relation between the instantaneous power and the average power. See here, average power is equal to half into F bar dot V bar. From this we can write instantaneous power. From this, P instantaneous is equal to 2 into average. This is the relation between the instantaneous power and the average power students. In the next class, I will explain you some applications based on the power students.